Hi, and welcome to this new video on basic ROS robotic theory. So in this video, we are going to tackle one of my favorite topics in robotics, which is AI, machine learning, deep learning, and everything that has to do with robots learning things by themselves. So why do you need it, and what can you do with it in robotics? So always AI and robotics have gone together because basically it's very difficult to make a machine do things that humans do by programming it. So in the last 30-40 years there has been more and more work on this matter, just because it's obvious that we need machines to learn by themselves very complex tasks. Otherwise, it's basically impossible to make them be robots. They are just machines programmed for doing one specific task. But robots are not that. Robots can pick objects, can understand what you say, can do whatever a human can do or more. And for that, we need AI. We need machine learning. So here I'm going to tackle a very, very small part of machine learning, which is clustering. It's one of the fundamentals for unsupervised learning. Unsupervised learning is essentially having the robot learn by itself. It's not that easy and it's not that pretty, but I'm going to just give it a glimpse. If you want to learn more, you have our course on machine learning is very thorough. You go over the basics, so linear regressions, and from that to what I'm going to show you, and learning. So learning based on clustered patterns and so on. So why do we need clustering? So let me show you. This is a snippet of the course, and this graph shows perfectly what I mean by and why do we need clustering. So to learn a pattern, and there's one exercise here, that we want the system, the robot, to learn, be able to know the difference between pattern, the blue pattern and the red pattern, okay? It's not that obvious, and making a function that matches this, it's really complex. So this is the perfect task for AI, for machine learning. So in this case, as you can see in the graph, we are giving this data to the robot already tagged. Already we are saying, okay, this is a pattern. The blue ones is one type of pattern and the red ones is another one. But in reality, the data doesn't have tags. So if you want a robot to learn by itself, by the input of data, it has to be able to cluster, to know what's the difference. So if he can see an object, see that that is an object and the table, for example, is another one, or the walls and a door and this kind of stuff. So that's the basis of clustering and why we need it, because we can't tell the robot what is everything. We can't put a tag to everything. And clustering is one of the bases of unsupervised learning. There are loads of other stuff. It's really big, really massive, this topic. But I want to show you a demonstration of how to do it in a real robot. So as always, we have our beloved robot. So let me just minimize myself. And let me launch our simulation. There we go. So we have our beloved simulation here. And what we want to do is generate data so that it can get the position of these objects and be able to know that they are different patterns. This you can do it with everything, but in this case is positional data, so X and Y position data. But it could be with camera data, sound data, anything. You can do clustering with absolutely anything with any dimension. It's just more difficult and you need some special set of tools, but essentially that's how it works. So the first thing that you need to do is let's generate our data. So for that, we are going to go here. I have one from previous, so I'm going to remove it. There we go. Scripts, and now I'm going to execute the Python run move laser. So let's go. So there you go. It's getting the data based on the laser that has here. So we are going to leave it do a complete turn. There we go. Okay. And now I'm going to stop it. I think I'm going to relaunch it again. I think it's faster. Okay, while we wait, I'm going to position the RViz to be able to now visualize those clusters that we've done with that data. We're going to see it in a minute. So there we go. We have our fantastic robots. Here we have our robots. There we go. And let me execute the other one, which is Python unsupervised clustering. Let's check that in results we have something. We do. And then let's execute. There we go. So we have this data. This data was generated by readings of the laser, moving the robot turning around. Okay, so yeah, we see that we have this. As you can see, this is the raw data. The robot doesn't know if this is part of this or this is part of this. He doesn't know because he doesn't understand the data. So there we go. It generated the clusters and there we go. So he generated basically that there's one cluster here, there's one other cluster here, one here and one here, which makes sense. So it got the data from the box here. He also got the data from the butter around here, and then it got some other around there. So essentially now I'm going to publish the centroids here. So as you can see, there's an error in the readings just because there's an error in the odometry, so it's drifting. But let me just zoom here and let's align it more or less how it's more or less like that. There we go. So as you can see, it got the patterns right, except this one. It got the butter here, it got the box here, and this one, I think that it's too close and the readings of the laser get errors. So that's another thing. But basically now we could feed this data to the machine learning algorithm and it would be able to learn how to avoid the obstacles, but based on machine learning, not deep learning, machine learning. And that's it. So if you want to know how to do this, how to use this data, check out the course. It helped me a lot because I really wanted to have a basis to explain this, and it really gave me this base of how to explain this. It's explained much more in detail, neural networks and other basic things, and also the clustering program. So you do the same thing but with a Turtlebot. So I highly recommend you that you do the course. And yeah, that's it for today. Thanks a lot. Give a like, subscribe, and see you in the next video. Peace.